all the when you all the preparation of the of these sorts, and then I will going to ask you.
Okay. Yes, sir. Done.
Write down all. Done.
So, one second. Yes, sir.
Okay, tell me that how will you prepare washing soda?
Washing soda. We heat NaHCO3 to give us Na2CO3 plus H2O plus Cl2.
Sure.
CO2.
Okay.
And the Na2CO3 is reacted with 10 H2O. I mean, sorry, added with 10 water molecules, which gives us Na2CO3 dot 10 H2O.
What is bleaching powder? Preparation of bleaching powder.
Which for a CaOH2 plus chlorine gas. Cl2 gives CaOCl2 plus H2O.
Baking soda.
Baking soda, NaCl plus H2O plus NH3 gives NaHCO3 plus H2O.
NaCl plus
H2O,
plus
NH3,
plus
plus CO3,
CO2.
CO2. Right.
That
Plus
gives.
CO2 gives NaHCO3 plus H2O.
What is the difference between baking soda and baking powder?
Baking soda and baking powder. Baking soda will be bitter and baking powder is not bitter.
Why it is?
And because it is what do you say? A strong base.
Baking soda. When we add edible acid like tartaric acid to baking soda, it become baking powder. Okay,
Okay, sir.
understood?
So as reference also we should just say that
I'm saying that when you add some edible acid like tartaric acid to baking soda, sodium hydrogen carbonate, then
turn
it
into
becomes
baking powder.
baking powder. Okay,
Okay, sir.
okay. Note it down here. What would happen if uh, uncontrolled heating is done during the preparation of POP? So let me tell you that what is POP. POP is plaster of Paris, which is calcium sulfate hemihydrate, CaSO4 dot half H2O. Okay, CaSO4 dot half H2O. This is chem. And how can we prepare it? By heating gypsum. Gypsum is CaSO4 dot 2H2O. And it should be done, and when we are just doing this one, it should be done at constant temperature. Okay,
Okay, sir.
understood?
Yes, sir.
And
It
that
should be
constant
heated at a
temperature is 100
specific.
degrees Celsius, according to the
Okay.
enzyme. Okay.
Okay, sir.
So, or 373 Kelvin. Okay, when you heat it, it will give you CaSO4 dot half H2O plus half water molecule will get evaporate. Okay, during the preparation of POP, the temperature should not rise above 100 degrees Celsius. Okay,
Okay, sir.
okay. So memorize it and then let me know. POP. Memorize it fast.
The formula, I mean the reaction,
Preparation, everything up to here.
the
Don't
water.
worry.
Okay, okay. Sir, what is the meaning of hemi? Hemi means half.
And hydrous. What? Which one?
Hemihydrate.
Hemi means half. Hydrate means water.
Okay.
It has half water molecule. That's why.
Okay. Yes, sir. Done.
Okay. So note it down in your copy first.
Okay, sir. Done.
Here the question comes that what would happen if uncontrolled heating is done during the formation of POP? So whole of the water crystalline when we do uncontrolled heating, no half calcium sulfate will be here. Okay, half water molecule will also get evaporated and will become anhydrous calcium sulfate, which is also called dead bond plaster. What we called it?
Dead burnt plaster or anhydrous calcium sulfate.
So note it down. First memorize it, then note it down. What would happen when if uncontrolled heating is done during formation of POP?
Okay, sir.
Done? Note it
Yes,
down.
sir. Okay, sir.
Done?
Yes, sir.
Okay, read it.
What would happen if uncontrolled heating is done in plaster of Paris? And the water molecules of gypsum will evaporate, resulting in anhydrous calcium sulfate.
Yes. All the water molecule of will get evaporated, and simply we'll say that no POP will be formed. It will become anhydrous calcium sulfate. Okay. Next, if I ask you one question here is that, for example, you have CaSO4, calcium sulfate, okay,
Okay.
and you heat it. Like for example, you have CaSO4, and if you kept it in open air, so what would happen? It will absorb the atmospheric, the water, half water molecule, 3 by 2 water molecule from the atmosphere. From atmosphere. What would happen? It will again become gypsum,
Yes.
which is
Abdul.
very hard mass.
Yes, sir. And which is what we are used to.
And that is of no use. Okay, you understood?
Yes, sir.
Question comes in your examination that what would happen if POP is kept in open air for a long time? So it will absorb the moisture from the atmosphere and will change into gypsum, which is hard mass and of no use.
Okay.
Done?
Yes, sir. Yes, sir.
What are the uses of POP? Have you written the reactions also?
No, sir. One second.
Noted. The above one also in the above question.
Yes, sir. That one I do. Yes, sir.
What are the uses of POP? POP, write down and note, memorize the uses that it is used in making decorative items craft. It is used for fixing fractured bones. It is used for making toys. It is used for making craft and patterns for boards and structures. It is used as fireproofing materials and essential for industries. It is used to fix small gaps and wall on roof. Okay, memorize it fast.
Sir.
Done.
Yes, sir.
Memorized.
Yes, sir.
Got it.
Sir.
Yes, you have to write it.
Yes, sir.
Okay. So today we shall be starting metals and non-metals. Okay.
Okay, sir.
This chapter is finished. So if I ask you that what are metals? Elements we have divided into three categories. One is metal, another one is metalloids, and the third one is non-metals. Okay. Metals
Okay.
are generally those substances, those elements that are generally having one or two or three electron in their outermost shell.
Okay.
Electron, these are metals. Metals that have electron in their last shell or outermost shell, you can say, or valence shell, you can say. While non-metals are those substances that have four, five, six, or seven electron in their outermost shell. Here is an exception. Exception is that hydrogen also has one electron in its outermost shell, and helium has two electrons in its outermost shell. So hydrogen and helium are the two metals that they are not metals. These are not metals. These are not metals. Okay, no,
Okay, sir.
these are not metal. Okay,
Yes, sir.
actually, hydrogen and helium. Helium is a noble gas, and hydrogen is neither a metal nor a non-metal. Okay, so we'll simply say here that hydrogen has one or two electron in the outermost shell. Still doesn't have. Okay, understood.
Yes, sir.
Next, if I'm talking about this one, that non-metals, metals have low ionization energy, means they can easily lose electrons. Why? For example, like sodium 281 electronic configuration. So it will lose one electron, it will become 28 stable electronic configuration to neon.
Yes, sir.
Okay. So
Okay.
they generally lose electron. If they have one, they cannot gain seven. If they have five electron, so they can it then it is a non-metal. It can gain electron, but non-metals always lose electron. Okay.
Yes.
Okay. While if I'm talking, so they have low ionization energy. Low
Ionization energy.
ionization energy means the amount of energy that is required to remove an electron
Okay.
from an atom. Now, if I'm talking here that they have low ionization energy, they have they have low electron gain enthalpy because non-metal can easily gain electrons, so they have low electron gain enthalpy. Enthalpy means energy. In terms of chemistry, we called it
Energy.
energy is considered to be as enthalpy. Okay,
Sorry, sorry, I didn't hear you.
energy is considered to be as enthalpy. Enthalpy. When someone
Enthalpy.
with electron, it become positively charged ion because electrons are being removed now, so it become positive. And
Okay.
positive ions is called cation. While,
Okay.
like for example, chloride 287, when it gains one electron, it becomes Cl minus. So it is anion. Okay,
Okay, sir.
understood?
Okay, sir.
So
Yes, sir.
memorize the difference between metallites and sorry, metals and non-metals. Done.
Yes, sir. Hello. Okay, sir.
So try to note it down. Done.
No, sir. Yes, sir. Done.
Okay. Which is the correct answer here?
Y is a non-metal and Z is a metal.
What are you saying?
Y is a non-metal and Z is a metal.
Y is a non-metal and Z is a metal. Okay. Good. Check whether if you did miss something, so you can check it.
Sir, non-metals have high electron gaining enthalpy, right?
Non-metal have, yeah, they have high electron gain enthalpy. Sorry, low electron gain enthalpy because they can easily gain electron. Na? Ionization energy is losing energy. Gain energy. Okay,
Okay, okay.
understood.
Yes, sir.
Next.
Sir, one second. Can you just show me the other slide once more?
What are you saying?
Can you just show me that first slide once more?
Mhm.
Okay.
Now
Okay.
moving to the special properties of metals, that what physical properties of metals. You know that
Okay.
iridium is the metal. Like metals generally have high densities, but iridium is a metal which has highest density. And while lithium is the metal which has lowest density, that is 0.5 gram per centimeter cube. So metals generally have high densities. Okay,
Okay.
which the highest is of iridium and lowest is of that is 0.5, that is of lithium. They generally have high melting and boiling point, except the tungsten, which is going the highest melting point. And gallium and cesium are the two metals that if you cap them on the palm, on your palm, and you rub it, they can easily melt. So gallium and cesium are I mean their melting point is near the room temperature. So our
Okay.
body is having 37 degrees Celsius temperature. So when you keep it in the palm, it will get melted. Okay. So gallium
Okay.
and cesium are the metals that can easily melt. Generally, mercury, we can say that generally solid, but mercury is a liquid at room temperature.
Okay.
Okay? Mercury is the uh,
Liquid.
lustrous and shiny. They are lustrous and shiny and malleable and ductile. Okay, they are malleable and ductile, can be drawn into thin sheet. Hard, but alkali metal like sodium and potassium are so soft that they can be easily cut with the help of knife. Okay,
Okay.
understood? Yes or no?
Yes.
So malleable means they can be drawn into thin sheet. Gold is the most malleable metal. Gold is the most
Most man.
valuable metal. Okay, understood?
Yes, sir.
So memorize it fast.
Sir, most malleable means easier or harder to
Okay.
be drawn to in sheets.
Malleable means that they can when you hammer it, it can be drawn into thin sheet. In
Okay, so
ductile,
when you say
it can be drawn
gold is more malleable, means it is harder to make it to thin sheets or easier.
easy to make into thin sheet.
Okay, sir. Yeah.
Memorize it first, then write.
Gallium and one
Gallium and cesium.
cetium. Okay, sir. Done.
Memorized.
Yes, sir.
Done.
Last one, sir. Yes, sir. Done.
Okay. So here we have malleable. Which is the most malleable metal?
Gold.
Most shiny,
Silver.
highest melting point,
Tungsten.
and the metal which has which can be easily cut. Sorry, which has melting point near room temperature.
Melting point near room temperature.
Hmm? Which one?
Gallium and Cethyl. Says
Cesium.
cesium.
Check the spelling.
Okay, cesium. Okay, cesium.
And here, if I'm talking about the non-metals, non-metals are opposite to the metals. If metals conduct electricity, non-metal do not conduct electricity. If metals are shiny, non-metals are dull. If metals are hard and malleable, then non-metals are brittle. They can be easily broken. So these are the exceptions for the non-metals property. Opposite properties of these are opposite. Exceptions are there because generally exceptions are being asked. Generally, metals are solid or gas. But bromine is the only non-metal that is liquid at room temperature. Which metal is liquid at room temperature?
Bromine.
This is a non-metal. Metal.
Metal. Mercury.
Yeah. They are bad conductor of heat and electricity except the graphite and allotrope of carbon. Graphite is an allotrope of carbon and diamonds is also allotrope. Allotropes are that substance that has same kinds of atoms, but their arrangements are different. Like in
Oh, okay.
graphite, carbons are arranged in hexagonal pattern like this way. Okay,
Okay, sir.
they are arranged in this way. So because of that, every carbon atom here is attached with three other carbon atoms. Their electrons are free because carbon has four electrons in our outermost shell. One electron is not participating. So that's why it is good conductor of electricity. But in diamond, each carbon atoms are arranged in a tetrahedral structure like this. Like this. So every carbon atom is bonded. This carbon is also bonded with four other carbon atoms like this way.
Okay, sir.
This carbon is also. So every carbon, so all carbons are bounded here, no free electrons. So that's why, but it is a specialized structure of diamond that in tetrahedral structure, like for example, if I'm having four carbon, one carbon here attached with the central carbon atom, this one, this one, this one, and this one. Okay. Okay.
Yeah.
Now this is the carbon atoms. Understood?
Yes, sir.
You know that if they are arranged like this way, these four carbon are attached, there is also a structure. But you see that if I apply the force on this carbon, the maximum force will act on this carbon.
Yes,
If
sir.
I apply the force on this carbon, the maximum force also act on this carbon. If I apply the
Okay.
force on this carbon, the maximum force exit on this carbon. And
Okay.
these two carbons are having a bond angle between 180 degree and these two are having 90 degree. So there is an unequal distribution of bond angle and force. But in diamond, there is a specialized characteristics of the tetrahedral structure that every bond angle and the structure is same. That if you apply the force from here, then it is applying on this carbon, this carbon, this carbon equally.
Oh, okay, sir.
Okay. If you apply on this, then it will be distributed one, two, three on all these carbon atoms. So that's
Okay.
why diamond is the hardest naturally occurring substance, which is very hard, which cannot be broken easily because of its tetrahedral structure. And in graphite, same pattern is in graphite, but they are arranged in hexagonal structure.
They're arranged in a
This,
hexagonal.
what do you say?
They're arranged in a hexagonal structure, right?
Yeah, this is a hexagonal structure.
Okay.
Okay, so that you will study in more detail in carbon and compound chapter. So hexagonal structure, due to hexagonal structure, each carbon atom is not bonded with four other carbon atoms. There is an electron free. That free electrons make graphite good conductor of electricity. So if I'm talking about this one, that bromine is the only non-metal that is liquid at room temperature, bad conductor of electricity. Like graphite is an allotrop of carbon,
Okay.
which is good conductor of electricity. They are really non-shiny, but iodine is a shiny non-metal. And allotrop of diamond. Diamond is also shiny. They are brittle, they can be easily broken, but diamond is the hardest naturally occurring substance. Okay, so memorize it and then you have to note it down.
Sir, even iodine is shiny, right?
Iodine is shiny.
Yes, sir.
Note it down.
Yes, sir.
Done?
Sir.
Okay, San. Then that's all for today. We'll meet you in the next class. Please be on time for the next time. Okay.
Sir, I was on time. I joined the other. They sent me one another link. I joined that class and sat there for some time.